I've been accumulating parts for the last few weeks. The primary part is this Reload 2 electronic load. It's made by a company called Arachnid Labs. And it's rated 12 watts at 3 amps. Now the 3 amp limitation may be built into the device. The 12 watt limitation is a function of the heat sink. And when one of these is assembled according to the instructions, we end up with something like this. This is a single turn 10K potentiometer. 2 binding posts, an extremely powerful FET mounted to a heatsink. Now all of this is included in the white box at a cost of $20. My intention, I'm going to install this heatsink instead. And on this heatsink, I'm going to mount a fan. I intend to replace the 10K one-turn potentiometer with a 10K 10-turn potentiometer. And I intend to do all of this twice and mount the loads, 2 of them, 2 potentiometers, 2 of these volt ammeters, in this plastic case that I have used before. So inside the case we'll have an Arachnid with a modified heat sink. On the front of the case we'll have a voltmeter ammeter, a 10-turn potentiometer, all of this stuff times 2, and then I'll have an on-off switch. I have a 4-pole switch here, but you could do it fine with a 3-pole switch. I intend to turn on and off the power, which controls the fans and illuminates these voltmeters, as well as one of the input terminals. That way we can't put power to an Arachnid without having power to the fans. On the back panel of the case, I intend to mount 2 more fans. I'm going to, as usual, as I do with most of these assemblies, here's a cutout. That is, you cut out this piece of paper, then you drill or you cut, as indicated, on the front panel. This one you would cut out and glue to the front panel. This provides a finished front panel display. I'm also providing a drilling template, probably this one, so that the fans can be mounted on the back panel. And I will probably drill some holes. These things will mount here, the heat sink. mount somewhere like this, and there'll be two of them. The fans on the back panel we mounted here. I'll probably drill some holes across the top for air to escape. My planned thermal management system, not designed, planned, is to blow air into the case with these two fans, blow air across the heat sink with these two fans, and then have the heated air exit the case through some holes on the top and maybe the sides. I'll provide links to all of the components, except I guess the switch and the 10K pots. I've got them out of my junk box, but these are both easily obtainable. I intend to power the entire unit with a 15-volt wall supply. And then regulate the 15 volts down to 12 volts with one of these miniature DC to DC converter. If you have accessible to you a 12-volt wall wart or a 12-volt power supply, you could certainly power the whole thing without one of these little devices. And although I'll provide links for the fan and the heat sinks, I urge you to try using some creativity maybe. These fan heat sink combinations are fairly available out of junk computers. But I'm going to try to use components I can identify and tell you where they come from. If you can save money by salvaging something from a computer or whatnot, feel free to do it. That's what this is all about. In order to make room in this cabinet, vertical room, I've eliminated, this is the Arachnid board, and it wouldn't be mounted to the back of the heat sink by this 3-terminal FET. I have eliminated 4 times 2, 8 of these mounting device. I don't know what these are for. I assume that people thought you could screw down a circuit board to some combination of these holes. They use up an inordinate amount of vertical space. So I just chopped off these, which will allow me to put the fan here with the attached Arachnid load here, times 2. Be another one over here. I've cut the drilling template out and I'm securing it with tape to one of the end plates. Now the template that I supply, and there'll be a link to this it's a PDF file, will be for a 50mm fan. You may have to modify it in the event you're using a different fan. Now I need to center punch all of the holes. I'll continue doing that until everything is center punched. Once all the holes have been center punched, we'll just tear this piece of paper off. I think we can remember that the 4 corner holes are for the fan, the center hole is for the coaxial power connector, and the rest are air holes. When you're prepared to drill holes in a panel like this, make sure you have all of your hardware assembled so that I know what size holes to drill here and I know what size holes to drill here. These holes are just as big as you can make them. In this case, I think I allowed for 5mm drills. When you're making panels from these templates, make sure that you actually have these devices on hand. My hole markings are just intended to be centers. They're not truly representative necessarily of the diameter of a hole. So to each his own. Gather up your hardware, or in the case of a front panel, the device is mounted on it, and tailor your holes to suit. The holes have been drilled, deburred. I did drill an additional hole to allow the wires to enter the case because I'm going to put my fans on the outside of the case. If you decide to put your fans inside the case, then just use this as the finger guard. Well, that's okay too.